Hello students, welcome back to the next video for Science of Grade 7. Today in this video we will discuss about mixtures which has been taken from Unit 8. To start with, in this unit we will learn about mixtures, compounds, solubility, solutions, chromatography. So the first slides, compounds. So what actually is a compound? A compound is a substance composed of two or more different elements joined by chemical bonds. As you can see, it's given in the slide. It is made of elements in a specific ratio that is always the same. It is represented with a chemical formula and only can be separated by chemical means and not physical. To give an example of a compound, when two elements, that is iron and sulfur, where iron is a metal and sulfur a non-metal, are heated, they combine together to form a compound called iron sulfide. What is a mixture? Mixture is a combination of two or more substances that are not chemically combined. Substances held together by physical forces, not chemical. In a mixture, no chemical changes takes place, and each item retains its properties in the mixture. They can be physically separated. For example, air is also a mixture. Air is a mixture of several different elements and compounds. Air contains nitrogen, oxygen, carbon dioxide, argon, neon, etc. In this slide, we will learn about alloys or metal mixtures. What are alloys? Alloys are metal mixtures with other elements. In general, alloys are considered metallic in nature. That is, they have good thermal and electrical conductivity. Alloys are a combination of metals or metals and other elements. Common examples of alloys: steel is a combination of iron, which is a metal, and carbon, a non-metal. Bronze, a combination of copper, a metal, and tin, metal, is also an example of alloy. A mixture of copper and zinc is also an alloy. Mineral water is also a mixture. It is a mixture of water and many other substances. The next slide we have is of making and separating mixtures. Mixtures contain different substances that are not combined together chemically. For example, if some iron fillings are mixed with the powdered sulfur, we can see the pieces of gray iron and yellow sulfur. If powdered carbon is mixed with the table salt, you can see the black carbon powder and the white salt. Given below are some of the methods of separating mixtures. 1. There is chromatography. 2. We have distillation. 3. Evaporation. And 4. Filtration. Chromatography. It is a separation of a mixture by passing it in solution or suspension or as a vapor through a medium in which the components move at different rates. Thin layer chromatography is a special type of chromatography used for separating and identifying mixtures that are or can be colored, especially pigments. Next, we have distillation. Distillation is an effective method to separate mixtures comprised of two or more liquids. Distillation is a purification process where the components of liquid mixture are vaporized and then condensed and isolated. In simple distillation, a mixture is heated and the most volatile component vaporizes at the lowest temperature. The vapor passes through a cooled tube, a condenser, where it condenses back into its liquid state. The condensate that is collected is called a distillate. A figure is provided in the next slide, which will help you to understand more. In the above given figure, we can see several important pieces of equipment. There is a heat source, a test tube with a one-hole stopper attached to a glass, elbow and rubber tubing. The rubber tubing is placed into a collection tube which is submerged in cold water. There are other more complicated assemblies for distillation that can also be used, especially to separate mixtures, which are comprised of pure liquids with boiling points that are close to one another. Evaporation. Evaporation is a technique used to separate out homogeneous mixtures where there is one or more dissolved solids. This method drives off the liquid components from the solid components. The process typically involves heating the mixture until no more liquid remains. Prior to using this method, the mixture should only contain one liquid component unless it is not important to isolate the liquid components. This is because all liquid components will evaporate over time. This method is suitable to separate a soluble solid from a liquid. Next, we have filtration. Filtration, in a simple word, is a separation method used to separate out pure substances in mixtures comprised of particles, some of which are large enough in size to be captured with a porous material. Particle size can vary considerably given the type of mixture. For example, stream water is a mixture that contains naturally occurring biological organisms like bacteria, viruses, and protozoans. Some water filters can filter out bacteria, but the length of which is on the order of 1 micron. Other mixtures like soil have relatively large particle sizes which can be filtered through something like a coffee filter. Chromatography, which briefly we have discussed earlier in the previous slides. So, once again, chromatography is the separation of a mixture by passing it in a solution or suspension or as a vapor, which I have already read before. So now let's learn what are the importance and uses of chromatography. Chromatography is an important biophysical technique that enables the separation, identification, and purification of the components of a mixture for qualitative and quantitative analysis. It is also used to study the dyes used in food. So, some of the uses of chromatography in our real life are: it can be used in a pharmaceutical company to determine the amount of each chemical found in the new product. It can also be used in the hospital to detect blood or alcohol levels in a patient's bloodstream. It can also be used in a law enforcement agency to compare a sample found at a crime scene to samples from suspect, and also can be used in the environmental agency to determine the level of pollutants in the water supply. These are a few of the examples where the uses of chromatography can be seen. Solutions. Solution is a mixture of solute and solvent. The substance that dissolves is called the solute, and the substance that it dissolves into is called the solvent. For example, the mixture of sugar and water is a solution, where sugar, which is in the solid state, is called the solute, and water in the liquid state is called as a solvent. A solid that dissolves in a solvent such as water is said to be soluble. For example, sodium chloride NaCl and sugar are soluble. NaCl, sodium chloride, as we can say, like the table salt, and sugar are soluble as it dissolves in water, whereas the solids that do not dissolve in water are said to be insoluble. Example, iron filings, chalk, etc., which cannot be dissolved in water, are considered to be insoluble. To understand more about solution, you can refer to your textbook, that is from page number 100, 101, 102, and 103. If you happen to go through the textbook, you will learn more with more examples which has been detailedly explained in your textbook. The given below are the assignments which are to be completed and sent to the mentors on or before 19th of December 2020. All the best, study well, stay safe, stay hopeful, and take care. God bless you.